Okay, I guess we are ready. I gave this talk at the Perl conference about 2 months ago, and it took about 45 minutes, so there should be plenty of time for questions and comments at the end, if you could leave those to the end. So this is battling a legacy schema with DBIc. First question is, who here has used or heard about DBIc? I guess hopefully most people. That's good. With what they would call a legacy schema? Yeah, 1 or 2. That's not a surprise. There will be live demos here, so just bear that in mind. Just a little bit about me. Well, first off, this presentation and the code is available at my website, lejo.github.io/code. And if you do have the internet connection up, I would suggest going there and following along, because there are code examples in the slides, and the contrast here isn't fantastic. So just a little bit about me. I work for this company called Give and Gain. We are a small non-profit based in the Swiss Alps. This is our website. About 12 months ago, this was a legacy CGI app using ModPerl, 15-year-old Perl code. ModPerl, classic signs of a legacy app. Last October, we released the rewrite, which is a modulicious stack with Moose and DBIc in the back end. I gave a talk at about 2 years ago on how we modernize the front end, how we used a plugin within Modulicious to migrate from CGI to Modulicious. So that was kind of the more front middleware. This is more about the back end. Let's go back to my slides. So, and some of the examples here are actually from the code we have in production. Obviously, I've sanitized some of the queries because obviously you don't know the schema. So just a little bit of an introduction to DBIc. My first intro to DBIc was about, I guess, 6 or 7 years ago. I was working for a payment service provider at the time, and I was tasked on rewriting the backend in about 4 weeks, so no pressure. Fortunately, the way we decided to do it was to create a brand new schema, so I could look at the old schema and figure out all the deficiencies there and not make those same mistakes in the new schema. So we could do sensible things like adding relationships, having sensible column definitions, and etc. And what happened is I started writing model code, and I started writing SQL and accessors. And after a couple of days of doing this and writing tests, I kind of realized, why am I doing this? There must be something out there that can do this for me. And it wasn't a trivial application. It was processing somewhere in the region of £5 or £6 billion a year, which is, it's not huge, but it's not small. And I was just thinking, why am I writing this SQL? What's the deal with this? So I did a bit of investigation and came across a few different ways to fix this problem on CPAN, and discovered DBIc. And played around with it, looked good, wrote some code, wrote some tests, and it allowed me to hit that 4-week deadline. In fact, it allowed me to hit that 4-week deadline quite early, so we could fix some of the bugs, tune it a little bit for the performance. And the schema was relatively trivial, so we didn't really hit those big problems. But I was conscious of the fact that you can hit those big problems further down the line. So I wanted to really be sure, is this the right tool for this job? And of course, I didn't want to make some of the mistakes that existed in the previous code. I'm quoting Ovid here, who I think was quoting George Spersky. Not leaking the abstraction is the big thing, and DBIc allows us to do that. Well, allows us to not leak the abstraction, I should say, just to make that clear. But it also has a lot of useful features, as we shall see in the examples that I'm going to present. Of course, as I said, other ORMs, DB toolkits are available. So just to expand on the model, there's a clear definition. Your ORM is not your model. It helps your model. And in a modern app, we tend to have this idea of a model view controller. And it's a bit misleading in that we see, you read it and think, oh, it's about 30% in each. And I don't think that's the case. We really want to have thin controllers. So the controller is just nice and small, and we have maybe some slightly bigger views because we're doing presentation, and then fat models, as Dom talked about 2 days ago. But also you have an ORM there, so again there's a clear separation from the ORM to the model. What I'm trying to do here is abstract the database away. So I'm calling the model code at the bottom here. I'm sorry, yeah, this is why I would suggest looking at the code online if you can. It's reveal up, so I can't make it any bigger either, I'm afraid. But basically what we have here is we are constructing a new class, an instance of a class, to get the information back. We're not calling dbic directly from our controller. Bit better? Okay, thanks. Thanks very much. So I have a little example of this here, which will show a little bit of the big stuff we're doing. So straight away it's throwing an exception, which you kind of expect because I've not passed it any meaningful data. But if I pass it an ID, that's what we get. So as you can see, I'm just constructing a class there. It's passing in an ID. It's returning the name. And the key is that the model code makes the decisions on storage. Now, further down the line, you might decide, actually, I don't want to speak to a database anymore. I want to speak to an API. Or just read a config file. You have that clear abstraction in your controller model code that they don't know about what's going on under the hood, which I guess is the key thing about object-oriented design. It's all encapsulated. And one good thing is we can better utilize exceptions. If our model code is throwing different types of exceptions, so we have here an exception database object that is thrown, or an exception input object that is thrown, we can handle that in the controller. We can say, oh, this is something wrong with the input, so we'll return a 400 with maybe a meaningful error. Or if it's something down in the database, we can throw a 500 and not actually report information that we shouldn't be reporting to the user. Okay, so getting into how I'm defining a legacy schema here. That's kind of the cynical way to look at it. Anything you didn't design yourself, but that's a little bit unfair, basically. But I find that schemas can grow organically, and that's often where you get that technical debt. Or maybe it's just used all the technology, so maybe it's an old version of MySQL, version 4, my ISM tables, no foreign keys. Or maybe it's just full of technical debt because we were trying to get the product out the door and make some money. Technical debt is very hard to fix within the database. It's like the ultimate technical debt. It's more like a mortgage. Missing a payment can be catastrophic, and it makes it very difficult to move. So I have a few typical examples of what I've seen in legacy schemas and what we can do with dbic to try and fix these. And I have taken a couple of these examples from this book, SQL Antipatterns, which is quite an interesting book to flick through. It has about 30 or 35 examples of antipatterns in databases. And that's not to say that all of them shouldn't be used. It's one or two examples actually are legitimate in certain use cases. So I'm using an example schema here. I tried to make something a bit more, a bit different to the typical CD database or whatever we typically have. And because we're based in the Swiss Alps, I thought I'd use the example of a ski resort. And it's sufficiently simple that I hope people can understand it. We have a resort which can have some pistes. It has installations like ski lifts. Obviously, pistes are linked to installations. And we have piece ratings and an installation type. So it seems, on the top, it seems sufficiently simple to demonstrate these examples, but as always, it's not that simple because it turns out that, well, a ski resort can be made up of many ski resorts, and lifts can actually be shared between resorts, and lifts don't remain static, they get upgraded. So again, it's that grown organically kind of thing. We thought we had a good schema, but we found out a year down the line, actually, this isn't very good. But that's not my legacy schema anyway, that's my legacy schema. So it's even more simple. And it's purposely simplistic, just to demonstrate the examples here. So the first thing you might want to do is, if you arrive at a company and you see the horrors, you might want to try and understand those horrors. And this is one application that's built up on top of DBIc, which is RapidApp. And that is a tool built on Catalyst and DBIc that allows us to explore the schema. So if I just fire this up. Assuming I've got my Pelvic Brew right version. Yeah, it looks like it's running, so that looks like Catalyst stuff to me. Okay, so it's accepting connections, which is good. So let's localhost, so makes it a bit bigger. Okay, so I've connected to my little SQL DB here. It's inspected the tables, generated the DBIc result source classes, and gives us a nice interface to play around with it. So we have our lift table, we can explore that. Result table. We can edit fields in here. So straight away, that's quite a powerful tool that's built on top of DBIc and Catalyst for us to explore a schema. If it was a better schema, we would actually see relationships within these tables, and we could actually input data using the joins and etc. So what you might find is, in the database you have confusing terminology. Tables that are named one thing but actually represent something else. Now if you have a clear abstraction in your model code from your ORM, it doesn't matter, because you could have a table named potato, but if your model class is actually named the correct thing, you can immediately understand it, because you're creating a new piece object, and the piece class knows actually I'm speaking to the table that's named potato, so it makes it clear immediately. We don't have any tables named potato, just to reassure you. And the big thing I find in legacy schemas is a lack of relationships, and it seems that, as I say, it's because old technology we didn't keep up, but I think there was once an aversion to these. The argument is that they're slow and actually they don't give us anything. They make queries complicated. But the R in RDMS is important, the relational database management system, so use it. And what we need to do first off is we need to generate some classes, because DBIc has a schema loader that will introspect your database and build the result source classes. Now if you have the relationships already defined in your database, it knows that this table links to this table, and there's very little for you to do. But if you don't have those relationships, you're going to need to tell dbic, actually this table links to this table. So the first thing you need to do is generate those result source classes on disk so you can actually append to them. And this is just a little shell script that calls DBIx schema loader to generate those classes. It's taking a few options there. I won't demonstrate it, but I can run this again and again to generate the classes. And because when you use dbic, it tells you everything above here is what I've generated. Everything below here you can add to. It uses a little checksum to make sure you don't fiddle around in the important bits of the definition. So there's a little comment there that says, okay, I've done this, you can play around down there. So I can regenerate this class over and over, happy in the knowledge that all my code below the fold is maintained. And what we do is, well, there's no relationship, so we have to tell dbic that this result sort class is related to that result sort class. And what we have here is a belongs to relationship, which tells me that this result source class actually links to this other result source class using this column to this column. And that gives us a trivial way to link through to the information we want to get. Obviously, if you have a huge schema, you might have hundreds of relationships. I don't think you need to add them all. You don't need to spend the days or the weeks going through adding all your relationships, adding all your tests. Just add them as necessary. As you're refactoring your code and writing your new code and realizing, oh, I need to join this table, add that relationship. And there are different types of relationship we can add to the class, obviously, to represent the different types of relationship we can use within dbic. Belongs to is actually the only real type of relationship in relational theory, because we only ever say a table belongs to another table. It doesn't work the other way around when we define a table definition. We don't say create table foo actually joins to something on the other side. It's the other way around. But dbic does have these utility methods to allow you to do that in your code, which can be quite nice. And it even has a many-to-many relationship, which allows you to join through a linking table. But Riba has told me that actually this is discouraged, because what happens is people put metadata within their linking tables, and they find that it's not easy to get that information out. So it's there if you really, really need it, but it's somewhat discouraged. It very much depends on the design of your database. So you might have an implicit relationship, but it might be one of these special kind of polymorphic relationships. And if you've ever seen this, basically we have a column in a table that tells us which is a foreign table. So we kind of have a source table, and we have the source ID, which links to the primary key of that table. And it seems like an elegant solution. People tell you, oh, we can link to any table. We can link to any other table in our database from this one table, which seems clever, but the reality is that you don't have any relational constraint actually within a database. You're pushing that logic up into your application layer. And we can fix this in dbic. We can actually tell dbic that this is a polymorphic relationship. So we can join on as many columns as we need to. We can pass it a code reference and say, the item source here is this table, the primary key is this table, and dbic will treat that as a normal relationship. We don't need to do any other special kind of method call within our code. So this is basically just an example of using, rather than a many-to-many relationship, we're using a search related. So I mentioned the many-to-many was discouraged, but what's the alternative? Well, we can search on a related table. It allows us to nest many different searches. So that's basically the alternative to many-to-many. We can kind of walk anywhere within the database, which is quite powerful. And if you have many of these polymorphic relationships, which I assume you would because it's a polymorphic relationship, you can just add as necessary, just using a little, just loop around and add the source tables. So it's quite trivial to do. Okay, so the next thing is fixing column data. So DBIc has the concept of filters and inflates, which allows us to expand column data to something else when we retrieve it in a search. And the one you'll almost certainly want is datetime. You have a timestamp or a date or a datetime column within your database, and it would be nice to get back a datetime object because it's trivial to do multiplication and addition and basically stuff most of us want to do with datetimes on that column. We don't have to do that within our SQL query. But if you still do want to do that within your SQL, because you're dealing with a legacy schema, so you might have the SQL with functions using datetime functions, you will come across the issue that actually some database engines use different syntax. There's no, I'm not aware of there being any real standard on this within the SQL standard. So MySQL will use datesub, PostgreSQL will use something else. Now what happens if down the line you decide, well, we want to migrate away from MySQL? You don't want to go and fix all the SQL that you've written to handle datetimes. You can use a little helper to do this. So I think this is from Fru, who has dozens, if not hundreds, of DBIc helpers on CPAN. And basically what we're just doing here is describing the operation we want to run in the SQL, and that knows how to translate it to a MySQLism or a PostgreSQLism or whatever. So again, we've removed the coupling to our database in the SQL. And this is one of the big aims, I think, of DBIc. It's meant to allow your model code to be database agnostic. You don't care what the database is behind the ORM. It knows how to construct the SQL and return the data. And to expand on filters, so perhaps you might have a char column in your database that should actually be a Boolean, which I think is a very common anti-pattern. And really you don't want to be having to run several if clauses on that. If you get a y back instead of a true, you're having to do, okay, is it defined, is it a y? Actually, it needs to be a regex because it could be a lowercase y or an uppercase y. You don't want to worry about that. You just want it to be a simple Boolean operation. And DBIc allows us to run filters on columns. So what we do here is we say, when we get this back from the database, run that little snippet of code to translate it to a Boolean. But obviously we need to still support the legacy schema. We can't store a Boolean in that char. We need it to be converted to a y or an n. So when we filter it to the storage, we do the inverse operation. And that turns what could be a several clause if block into a simple one-line call, as you see down at the bottom. And we can go beyond that. So another anti-pattern you might have seen is someone storing a CSV in a column. Perhaps this is linking to several different tables, or perhaps it's just CSV data that they didn't correctly put into a third table. And again, if we are bringing this back from the database, it would be nice to get an array rather than a list of comma separated values. And what I'm doing here is I'm just splitting it rather than using text CSV to make it a bit more obvious. But I would use obviously text CSV in any actual code. But I'm just basically saying here, when I get it back, just give me the split so I get an array back. Now, what's powerful here is when we filter it back to the database, we might want to do some sanity checking on that column data. So if this if this column is actually a reference to several other tables, we might want to say, actually, does the ID it links to exist? And if not, perhaps handle that somehow. And because this is in our results source class, it's transparent. We can sort of manually enforce referential integrity there. Okay, so that's all well and good, but if you have a legacy schema, you've probably got some pretty complex, hairy queries that you really don't want to translate into SQL abstract. Or you might want to do it, but it would become something that's difficult to understand to people that aren't familiar with SQL abstract or DBIc. And there are several options to do this. And this isn't necessarily the sign of a legacy schema, because I'm sure we have some very, very well written schemas, but we still have complex queries. It's the nature of modeling that data. So I think one of the recommended one is just to use DBHDo. DBIc it's not a dogmatic solution to a database. It allows you to do what you want. If you decide I want to just write some normal SQL, it allows you to do that. So we can call a DBHDo on our DBIc storage object and just pass it some SQL. Using DBHDo here rather than accessing the raw database handle gives us access to the exception handling of DBIc. So this is the recommended way to do it. Another way we can do this is using virtual views. So I'm sure we're all aware of what a view is, but we can define that on the ORM side. And what will happen here is DBIc will treat this as if it was a table. So we can write our complex SQL here and write our column definitions here. And we will get back an object that gives us the information. Note you probably can't see it, but there is a isVirtual flag there, because it doesn't exist in the database. It's a virtual view. So it turns our complex SQL again into a single query, a single call on DBIc. The problem with virtual views is we're kind of restricted to the number of bind params we can use within the query. If we want to have a subtle variation of that complex query, we need to create another class and write the SQL again, and it's becoming unmaintainable. But virtual views are just Perl classes, so we can trivially take one as a base class and extend it. So if you imagine you have a 200-line SQL query and then you have 3 different variations of the bind params, well, here we're just using the base class and saying, right, actually I want to tack on this bind param here. So saving yourself a lot of code and repetition there. And there is Ovid's DBIxClass report module on CPAN, which I believe just generates a virtual view for you under the hood. So you can, let's have a look at that. I'll show you the synopsis. So we can, if we want to, we can put our SQL code within our model code, and then it will construct a virtual view. And as you can see there, it's quite trivial. But you might, as I say, you might want to push that down into the result source classes of the ORM. So if you're using DBIc, it's relatively new to you, you might want to switch on some of the debugging when you're developing. DBIc has these query trace and profiling options, allowing you to see the raw SQL that is being generated against the schema. And one of the additions I usually find myself adding is a little bit of code to tell me where the query came from. And this is quite a useful thing in the concept of optimizing queries in terms of prefetching. And you probably want these as well, connection options. Now this obviously depends on your database engine. But if this is new code that's speaking to your legacy schema, you might decide that you want to start fixing any issues. You don't just want to take your old SQL and map it to DBIc, SQL abstract. Because if this is a new code, well, we can, for example, here with MySQL, we can switch on strict mode. And that will reveal any issues with our SQL that could then lead to us refactoring, perhaps, those queries. And here we're using auto reconnect and enabling UTF. Now, obviously, that depends on your database tables being UTF-8 compliant. And of course, there are gotchas. One of the things I hear a lot about ORMs is they're slow, but I don't think that's the case. If it's slow, you're probably not using it correctly. You're probably not prefetching. Maybe your SQL is not quite right. Maybe you need to rewrite that SQL using a virtual view or using DBHDo because DBIc isn't quite generating the right thing for your needs. Or maybe you need to force an index. And I find using prefetch as much as possible is the biggest optimization step you can take, because if you have two nested for each loops, suddenly you can find your queries count going exponential, which is never a good thing. The cost of the time spent generally these days is going over the network. Our code runs pretty quickly, and our databases tend to have an awful lot of memory be running on an SSD with a really good query cache. That's probably not going to be the point where you're slow for most of your queries. But if you're going back and forth all the time, well, that's going to cost you. And that, again, you should test your app with, obviously, a representative data set, if possible. Because if you're running this against a small DevDB that's only a few hundred megabytes, and you send it out to your live database, which is orders of magnitude bigger, then you might suddenly see the issue. And yeah, keep your result source classes up to date. The shell script that I showed at the start to regenerate those, obviously whenever you make a database change, regenerate your classes. You won't find the problem until you run a query live and DBIc suddenly says, actually, hey, what's this column? I don't know about that. That's what you'll get if you don't regenerate the classes. So just a quick summary. Separation of concerns and having thin controllers and a fat model. And the ORM is not your model. It's there to assist your model. And as I said, DBIxClass, it's not an opinionated framework. It allows you to do what you want in a way you want to do it. And you can define relationships even if they don't exist. It's quite flexible. And filters are very, very useful, because often I find that column data isn't quite right, data types aren't quite right. We want to get objects back. But you can go down to the low-level handle if you have a complex query. And there's a load of stuff that I didn't cover. As I mentioned, Flu has an awful lot of DBIc-related modules on CPAN. So there's useful stuff for logging and debugging. There's quite a powerful deployment handler for schema versioning. And just to look at the helpers, there are, I think, over 100 the last time I checked. Yeah, quite a few there. So if need to fix solve a problem, it's probably there. And there's an awful lot built on top of DBIc. The last time I ran this query against CPAN-M, meta-CPAN, sorry, there was over, I think, well over 100 distributions of the form DBIxClass. Okay, that went quite quickly because I didn't show really any examples, because it's very difficult to switch like this. But if people want, I can show examples, or if people have any questions. Okay, I'll pass the mic out.
What I really don't understand is what's the fat in the fat model? It's basically you add some relations to the thing, but what's more fat in that?
So I think this term model can be a bit overloaded. What my opinion of it is, we encapsulate the business logic within the model code, which makes it a fat model. We don't do that in our controllers because we're coupling ourselves. We're coupling our web framework to our application code. So if I suddenly decide actually Modulicious isn't for us, we want to use Dancer 2, all that code is in the controller, that's not good. But if we push it down into our model code, that becomes more trivial. So the controller should be just really a thin wrapper around your models. It's not leaking the abstraction. So they know about the database, but they probably know about other business critical functions as well. Okay, anybody else?
Excuse me, about legacy code. There is some limitation where I'm working with Oracle database because some usual things is not working on there. For example, I need to or a home variable to working with Oracle. Is there some limitation, or you have some experience with Oracle database?
Does DBIc have some limitations with Oracle?
Because usually I cannot build DBIc. It's asking me some special environment. So is Oracle database is if you want to work with this in parallel, you need to install a Oracle instant client to work. So maybe some experience.
I've only used DBIc with SQLite, MySQL, and Infamix. I think it was a while back. I haven't used it with Oracle. Now my understanding is it has quite wide support for database drivers. So I'm sure that somebody has, if you do have a problem with Oracle and DBIx, somebody's probably come across that problem already. So I would encourage you to speak to the people on the mailing list or in the IRC channel, which I think is there. Yeah, okay. Any more questions?
So this is not a question as much as a comment about the things you talked about with finding out what queries are actually being run. And I ran into pretty much the same problem, or they're having the same situation. So I wrote a model called test dbic expected queries. So you can run your code within a code block in the test, and then you can declare what kind of queries you want, and if it's not what you expected, then it will list the queries, and it can also give you a stack trace of where they were called. So that could be useful as well for this.
That's so that module to test that the query generated by DBIc is what you want it to be is probably very useful, and probably will be very useful in the future, because I believe they're doing some refactoring in the query generation. So yeah, certainly I would look into that. Any more questions?
Do you have any tricks or ideas on how to deal with relationships that the database cannot really handle? Like I usually have a import date as a column, and if I want to run a report for a certain day, I pass that report date for the loaded data in, but I cannot create a primary key for that table without also referencing that loading date, and I don't always want to use that report date. So basically, can you use this without primary keys is, I think, my question.
Yes, you can, I think, because as I showed with the polymorphic relationships, you can use a subroutine, anonymous subroutine, to join any number of columns to any other columns in any other different tables. So probably it can solve your problem for you. Any more questions?
You were saying that you have to update the abstraction classes after you change the model. Can't you automate this, that it checks every time if something changed and then updates it automatically?
Yeah, as far as I'm aware, you can probably use the deployment handler plugin, and there are other DB versioning modules and scripts out there. And obviously you would want that as part of your test suite. So perhaps whenever you check in your code, it runs a shell script to generate the classes again. And if there's a change, the tests fail. So I'm sure it's trivial to implement. Yeah.
I actually have a question to the audience. I'm just interested in how many of you are using Sybase with DBIxClass. Is there anyone here? But you're using Sybase, but DBIxClass together with Sybase. Okay, so we're using it at our company, and we're also battling with the legacy Schema. So I find that really helpful. Just wanted to know how many people are there.
Okay, great. Yeah, well, I don't know of, as I said, I don't have any issues with Sybase or Oracle, but I'm sure if you ask on the IRC channel, they will come back to you straight away. Okay, any more questions? Yeah.
Sorry if it's a stupid question, but I'm not too deep into SQL. The rumor is that ORMs have a problem because the model doesn't really fit into the relational model, which can be projected into a database, because it's an object class model and it's another world, but there are restrictions. So, but you said DBIxClass isn't opinionated, so you have a flexibility to adapt to this?
Yeah, again, obviously your model code the idea is to make it loosely coupled to the ORM. So if you do have, say for example, you have a user class, and actually you're joining that to some privileges, it's all about finding the balance of the code within the user class and then the relationships within the results source classes. So you're always going to have some coupling, I think, with your model and your database, your ORM. It's trying to keep it as little as possible. I was having quite an interesting conversation on the first night. Somebody was of the opinion that what you should really do is define an API for your database. So in your database you have lots of stored procedures and functions, but you're still having to call your database. So maybe you gain something, but I think you lose something. Does that answer your question, I think? Yeah. Okay. Yeah. Okay. Any more questions? Yeah. Good.
I actually experienced some performance issues with respect to DBI, and especially if you use prefetch on DBI as well, or you can precompile some stuff. Actually, DBI can be much faster than DBIc. And did you experience the situations in which DBIxClass was too slow, or?
Yeah. So if you're adding another layer, it's always going to add some overhead. But as I mentioned, I think our ideas about where the overhead has changed over the years. Everything is, we have so much RAM now, we have SSDs, we have quick network. Your bottlenecks probably aren't that important. Now if you're a Facebook or a Google or a Booking, then obviously you have an awful lot of traffic. You're going to run into these issues, and this is probably not the right solution for you. So always benchmark your code and profile it and see, actually this is a big bottleneck. Maybe it is a big bottleneck, but certainly from our use, it's the pros and the cons. It's saved us so much time and frustration in rewriting some of our code. Some of the pages on our site are extremely heavy. We have the explore page, which has to generate so many different queries, and obviously this is probably running under the hood. It's probably running close to 100 queries. But we stick it in memcache. If it's a heavy query, we're going to cache it anyway. So you'll hit that problem once, maybe once a day, and then it's all cached. So again, our ideas about bottlenecks and where the problems are, I think, have changed over the years.
A few things about performance. Relatively recent versions of DBIxClass are considerably faster than they used to be, which is absolutely awesome. Plus, some of the work you can do if you're looking at read-only data sets using using DBIxClass views, the virtual views, or the DBIxClass report, both allow you to create your own custom data types, or you can also fetch raw results from DBIxClass raw data without necessarily building the entire result object if you don't want to. There are multiple strategies for it. Whenever I develop with it, it is particularly, with our project, we're using Schema Loader for everything. We make a database change, we apply it with Sketch, recreate our schema, and for many of my clients, what is, many hours of work sometimes is reduced down to just a few minutes, and it is well worth the occasional performance issue. I rarely run into anything significant with it anymore, even though I used to. So I would say, if you haven't checked it out recently, do check it out, look at the virtual views and other tools out there for it.
Yeah, and I think if we do run into performance issues, we'll probably move our medium AWS DB instance to a large AWS DB instance. So, as I said, our ideas about where the bottlenecks are have changed over the years. Any more questions? No? Okay, thank you very much.